Okay, well, thank you for coming. What I would like to do today is tell you about some research that we've been doing looking at land change in Latin America. But really my goal in this is to share with you a web application that we've developed over the last year and get feedback from you guys on what you think about it and how we can use this in different parts of the world. To give you a little bit of background, about 6 years ago, I started a project called RBMON, the Automated Remote Biodiversity Monitoring Network. And this is work that I've been doing with Carlos Corrada. He's a computer scientist at the University of Puerto Rico, where I'm in the biology department. And we started with a grant to monitor biodiversity using acoustic recordings. And that's where the project started. We developed hardware and software to try to do real-time monitoring of biodiversity based on acoustics. At the same time, I had a project with another group of people where we were looking at the land change in Latin America, and that's going to be the data that I'm going to share with you today. But Carlos was always hearing about this project, and then the last year we decided to fuse the two of them. I'll show you during the talk what they have in common, but clearly for this audience, I hope that this is what interests you. The other thing that was been fun about this project, it's been done with the help of many students, graduate students and undergraduates, but most of them have been in computer science. And one of the things that I found out doing this project, it was much easier to teach computer science students the biology they needed to know than to teach biologists like me the math and programming skills. So it's been a fun experience for me to work with people in computer science. The project, it's new, so it has different names. Sometimes we call it land transparency. Sometimes we call the application land mapper. We'll get to that later. But the goal of it is to provide a user-friendly platform for creating and sharing up-to-date and accurate information on land change around the world. Okay? And what we want to do is make it so that the user doesn't need to invest in expensive servers or have system administrators. We want to do that work for them. You know? They don't need to be remote sensing experts or GIS experts. What we're looking at are people that know their study site. They need maps, they need current maps, and we're trying to provide a tool that allows them to do that. And so what we've done is we've created this web application. We are still working on having an open access server with maps, data, and other projects. And what we want to do is a diversity of outreach activities to promote this network. And this is the first time we've done this. This is the first time I've talked about this project to any group. And you know, I'm lucky that I was able to come for this workshop that's going to start tomorrow. But if I could have chosen a group, an audience that I would like to have presented it to, you guys are the ones that I would like to get feedback on what you think about the system. So the first thing we did is that we were very interested in coming up with a land classification methodology that allows for the detection of both deforestation and reforestation. You know, there are a few analyses that in the same analysis that are permitting there to be reforestation. And a couple of years ago, I did a review with Greg Asner and some other people to look at, you know, what is the state of tropical forest. The deforestation was all based on remote sensing data. The reforestation was based on literature review. It's kind of hard to compare hard numbers from remote sensing with literature reviews on reforestation. And in part because I live in Puerto Rico, forest cover in Puerto Rico has gone from 5% in the 30s and 40s to 55% forest cover today. At least in the context of Puerto Rico, it's important to understand the reforestation process. And so we wanted to come up with a system that in the same analysis would give you the opportunity to detect reforestation or deforestation. And we did this by taking advantage of Google Earth, where we have high resolution images to get good training and validation data. We combine that information with data from MODIS, over the last 10 to 12 years. We combine this information using random forest tree classifiers and then producing a land use map. One of the things that we're doing different is that we're producing a map for every year. It's not producing just 2 points and looking at the difference. And I'm going to show you a little bit more of this in detail here. Unfortunately, most of the data I'm going to show is not for this 12-year period. It's for 10 years. I was a little too optimistic in how far we would get with the analysis, but it's roughly, it's the same process and hopefully roughly the same patterns. In the data I'm going to show, we worked at the municipality scale. You can see at this, in this map, we were using hexagons. This is Medellin in Colombia. You can see a couple of dams. The green is our class of woody vegetation. That would include shrubs and trees with over 80% cover in a single modus, 250 by 250 pixel. The important thing that we did that was different is we produced annual land maps for each of the 10 years. Now we have it for 12 years for most of Latin America, and hopefully in February we'll have it for 13 years, for 2013. And so what we can do is go into each one of these hexagons or each municipality, and we can count up how many pixels were classified as woody vegetation or trees in 2001. Make a new map for 2002 and do the same thing. And then what we would do for each municipality or at each hexagon is look at the relationship or the correlation over those 10 or 12 years to see if there was a significant trend in the change of the vegetation. Okay? So again, we're not taking just 2 points. We're using all the data from all the years to see this municipality where you can see the amount of woody vegetation decline. We had a significant decline. Another municipality that's just kind of all over the board. There was no significant 10-year trend. And then here we have a municipality or a hexagon where there was a positive trend, reforestation. Okay? So in the original work that we did, it was with this group of people. David Carr is here, not here right now, but here for the meeting starting tomorrow. And these are the results. For 2001 to 2010, we looked at more than 16,000 municipalities in all of Latin America. The red dots are municipalities that had a significant 10-year trend in deforestation, and the green dots were a significant 10-year trend in reforestation. Okay? We're showing about 2,500 municipalities. The other 14,000 municipalities did not have a significant trend in one way or the other, in one direction or the other. Deforestation was the dominant land change. You know, here's the arc of deforestation in Brazil. There's probably other favorite places of yours that are being deforested, but the surprise in this map for us and for most people is the number of green dots, municipalities that had a significant 10-year trend in reforestation. When we did this work, we were trying to look at, we did it at the municipality scale because we also could get demographic data on each of the 16,000 municipalities and all other socioeconomic variables. One of the things that we expected was there would be, you know, a clear relationship between population change and land use change, and we didn't see that. And I'll show you some more information on that later. So, deforestation wins, but not by much. And again, you have to be careful with this because, you know, we all know that the areas that are getting deforested are high diversity, high biomass, while the places that are reforesting are low diversity, low biomass. One of the things you might have noticed that a lot of the areas that are reforesting are in drier areas. The places that are deforesting are in mainly in the Amazon. So you can't just subtract these two numbers, okay? But still, this is, yeah, at least we're starting to get it, in one analysis, the opportunity of comparing where places are being reforesting and where areas are deforesting. For this group, you know, I don't think I need to lecture on deforestation. So what I thought I'd do is just show you the other side of the coin. Show you some of the places where new forests are coming back and try to understand what's going on there. And let's start in the Caribbean. Virtually all countries had municipalities that had significant reforestation, significant deforestation. In this case, the net change for the Caribbean was positive, and virtually all of that change occurred in Cuba. Anybody have any idea what was going on here in Cuba? Why is Cuba reforesting? No? I'll give you a clue. It's related to sugarcane. Anybody have an idea now? Okay. From the 1960s to the 1990s, Cuba has approximately 1.4 million hectares in sugarcane. The end of the Soviet, or the subsidies of the Soviet Union, we see a dramatic decrease in the area in sugarcane. They lose almost 1 million hectares of sugarcane. And so this process starts in the early 1900s. We're looking at this time period here, 2001 to 2010, and we're identifying woody vegetation coming back in these areas that had been previously classified as agriculture. And so what did we get? One exotic African species. It's called marabu. It's a legume. And so, you know, one of the things that you have to be careful when you do this type of work is to go in and also understand the details on the ground. We went from one exotic agricultural species to virtually one exotic legume species. Another area that was surprising and very interesting was in the Chihuahuan Desert of northern Mexico. We had a lot of areas that were showing a 10-year increase in woody vegetation. Remember, these aren't forests. Our class included shrubs, but each pixel had to have over 80% cover, or close to 80% cover of shrubs to be classified as woody. And trying to understand what was going on in this area, one of the things that's clear is the violence has been associated with drugs in northern Mexico. Here's a figure from The Economist showing that in 2010 there were over 40,000 homicides associated with the drug trade. Clearly this violence could have an impact on agriculture, the abandonment of agricultural land, but also at the same time, what was interesting, in these three northern states of Mexico, they had high levels of rainfall. This was the average rainfall from 1940s through 2000, so a 60-year record. And here's the rainfall during the period that we were studying it. So you have this interaction, it appears to be violence, abandonment of agriculture, higher rainfall than normal, and that's reflected in an increase in shrub encroachment in these areas. This one's for you, Susanna. Here is the Pacific coast of Mexico, Oaxaca, and Central America. You can see that there are many, many small municipalities, but many of these municipalities are increasing in their woody vegetation. It's likely that this is related to migration, remittance, and this is something that we're going to be talking about the next few days here. Now let's go to South America. We see another area of increased woody vegetation in the Andes of Colombia and Ecuador. Again, we have the theme of rural violence in Colombia between the guerrillas, the paramilitares, and the army. We've had out-migration from many of the Andean areas. There have also been strong economic opportunities in major cities and rural urban migration. And one of the things that you see is the three major cities in Colombia, Guayaquil and Quito in Ecuador, between 1992, 2008, they all grew almost over 1 million people. So there was a lot of movement into these cities. Another analysis that we did that was the first time that I had ever worked with nighttime lights, what we did was outline in 2009 the limit of the urban area of Quito, and then we looked at the highest intensity of light, and this allowed, and we can go back into time. So if we go back to 92, the highest intensity of light was just restricted to this area that's here in darker green. And you can see how it is expanded out in 2000 and 2009. So we're assuming that this movement of people out of these areas into the major cities could be something that's contributing to the reforestation in these areas. And the last area that I want to talk about, which was a big surprise for me, is in northeastern Brazil, in the Katanga, in the dry shrub areas of this region. When we saw this, the first thing I did was, first I have never been in this part of Brazil, but I had always associated this with an area of desertification. And there still are processes of desertification, but our data suggest that there's also a lot of reforestation going on there. So when we tried to understand better, one of the things that we found similar in northern Mexico, over the 10-year period of 95 to 2005, there was an increase in rainfall in that region. It was also an area where the Lula government made a lot of investment in infrastructure and education, which may have increased rural-urban migration. The other thing that we found is when you go to the agricultural records in Brazil, there was decreased agricultural activity in these crops. And so all these interacting factors could help to explain why we found this increase of woody vegetation in this region. Okay. So clearly, we detected a lot more reforestation than we expected, but deforestation continues to be the major process that's occurring in South America. And so I don't want to misguide you in thinking that everything looks good. There's clearly lots of areas that are being deforested in Brazil, in Paraguay, Argentina, and Bolivia, and throughout all the countries. In this figure here, what we had set out to look for originally is that what was the relationship between the population in these 16,000 municipalities and land use change. And you could have expected that here we have change in population, so this would be a decrease, here's an increase. This is our correlation in change in woody vegetation, reforestation versus deforestation. And you could expect that if you lose population, you'd have reforestation, and then as you increase population, more deforestation. Clearly, at the scale of the municipality and analyzing those 16,000 municipalities, we didn't find a clear relationship. Doesn't mean that people don't count. But we're making the argument that it's the global population that's driving a lot of this deforestation instead of the local population. And one thing that we think is an important factor in this is global meat consumption. And so in this figure, what I'm showing is global pig and poultry production from 1994 to 2010. And you can see this incredible increase. And on the other axis, I'm showing how the area of soybean fields has expanded over the same period. Okay? You can see there's a very tight correlation between these two. I don't think, this huge increase in soybean production is not going to produce tofu or soy milk. No, this is feed for pigs and chickens. Okay? The other component of the global meat consumption is beef. And so we did something similar. We looked at exports of meat from South America, and we looked at the pasture lands. And one of the things that's interesting, if you look in the 1990s, there's not a very clear correlation between these two. Exports is rather flat, and then there's ups and downs in pasture. But in the since 2002, both, there seems to be a much stronger correlation between the amount of exports of beef out of South America and the area that's being used for cattle production. This interaction between pasture lands and agriculture, we've looked at tried to look at it in a little different way. And I want to take some time to, before I show you this crazy map of colors, explain this figure here. Now remember, for each, in this case, hexagons, we have 10 years of data. And so on this axis here, we're looking at herbaceous vegetation. Was there a significant increase or decrease over that 10-year period? So you could think of this as pastures. Here are croplands. Was there a significant loss of croplands or a significant increase in croplands? So let's start with the green. This green here is not forest. This green is representing a very strong increase in herbaceous pasture lands, but not really much of a change in agriculture. You see that? Is that see? So the arc of deforestation here, we're getting a big increase in pasture lands, and this is at the cost of deforestation of forest. Okay, now let's go look at colors of orange. And one of the areas that I know best is in northwestern Argentina. This is blowing up a little bit. And we find a very different trend. Here, there's no change in herbaceous vegetation, but there's a big increase in agriculture lands. These areas here are the dry forest of the Chaco, and they're being deforested and converted directly into agricultural lands, specifically for soybeans. Okay? Let's go around now and look at purple. One of the the growers will argue is that they're not doing that much deforestation. They're just changing other crops or pasture lands into soybean agriculture. And they're right if you go to the Pampas in Argentina. So this is areas where there's been a loss of pasture lands and a big gain in agriculture. So this means these are pasture lands that have been converted into new agricultural lands. We continue to go around. Where do we see sort of black or gray? One example is what I showed you before. Along the Pacific coast of Central America, these are areas where there's not a big change in agriculture, but there's a loss in herbaceous or pasture lands. So these are areas where marginal agriculture, marginal pasture lands could be being abandoned, and this is why we're seeing forests starting to come back in this region. I don't think there are many red areas on the map, but blue, which would be not much change in herbaceous, but a loss of pasture or of agriculture, is most notably in the Caribbean. And again, this is probably similar to what we saw in Cuba, where you've had loss of subsidies, mainly for sugarcane, and sugarcane is disappearing from many of the Caribbean islands. So that's it for the data and the results on land use in Latin America and the Caribbean. And what I'd like to do in this last part is show you the web application that we've developed. And really what we've done is to continue this work, trying to make it easier for me to do this, but it's a tool that we're not producing just for our lab. It's something that we would like to share with the community. So it's a web-based tool that has many different components to it. The first component is this. We're taking advantage of the high-resolution images that are in Google Earth. And the flow of the work is the following. We're using Google Earth to collect training and validation polygons using those high-resolution images. We can go into pastures and you can see the cattle on the pastures. You don't have any doubt how that land is being used. The second part is we have brought in all of the images from MODIS. We hope to do similar work with Landsat, with Spot, with QuickBird, with other images, but right now we've brought in all of the images for MODIS from 2001 to 2012 for Latin America. We're also in the process of downloading all of the images and processing those MODIS images for Africa as well. Okay, so you collect your training data, the image, you decide on what images that you're going to want to analyze, you create a classification algorithm, we give the user different options to choose from, you evaluate this classification error, or the error matrix, you see, have I done good enough work? Am I happy with the ability of the classification algorithm to distinguish my different classes? When you're happy, you make a map, and we're developing another tool to actually evaluate the maps that we're using. So let me show you now the first step to collect training data. We zoom in. This is in Mexico. Don't have any doubt that these are trees. The user can define all of the classes that they would like to use. These boxes here are, here it is, MODIS data pixel grid. So we're showing each individual pixel in MODIS, and I've gone in with a drawing tool and I've selected these 4 pixels. Okay? The program, we use the date of the image, so the program pulls the date out of the image. The user assigns which class it is, and then that information is sent to the database associated with each project. Okay? The program marks the area, shows you where you have your training data. Here I've gone over here, made another training polygon for herbaceous. You go through this process, getting hundreds or thousands of different polygons around the region that you would like to classify or make your maps for. When you've done that, now it's time to make the classification algorithm. And we have a series of drop-down options. So here, first it's asking what type of machine learning algorithm do you want to use? And we give options. When you choose random forest, it provides the parameters that you can change to improve or the classifier. It next wants to ask you what images that you're going to use and what variables that we provide for these particular images. Then you tell it which area do you want to use the polygons. Where have you done your training data? In this case, I'm saying Mexico, but it could be, say, the dry forest biome in Mexico. And then it would pull out just those polygons, the training data that we've created in that area. Next, it's going to show you all of the polygons and the pixels in those polygons for your different classes. Yeah? You have the option of using all 100% of these, or you could hold some of those polygons out to train or to validate or the system using some percentages of this. You can see in this case that it's there's 15,000 pixels that were used to identify trees, and so it's not very balanced. The user can come in and add the number of pixels that they want. Once you've run that, then you get the error matrix. You can evaluate how good it is. You can determine if you need to go back and make more training data to improve this. And then once you're happy with your classification, then you can apply that to anywhere that you would like to use it. Hopefully in the areas where you actually made the training and validation data. In this case, I'm showing you a map that we just made for all years from 2001 through 2002. This is the Madre de Dios department in Peru. Here is the border with Bolivia. Here is the Transoceanica Highway, and the city of Puerto Maldonado would be here. Here I'm just going to show you the two extreme years. And one of the things that you can notice is that there's been some change along this highway, but the big change in this region has been gold mining. And you look in this area here, and you can see the expansion of gold mining in this region and in this area. This is the Tambopata National Reserve. This is the buffer zone, and you can see that the gold mining is entering into this area there. The other thing that we were working on that we felt was important is that, okay, we have the train, we are clearly showing how good the algorithm is, but the most important thing is the final maps that we're using that we're publishing, that we're calculating the data on. And so one of the things that we decided we would like to do is create a tool that actually allows the user to go back in and evaluate the final map. And it will do that by going in, randomly pulling out pixels where there's high resolution images. It will ask the user to classify this, either the dominant class or maybe proportions of woody vegetation and herbaceous vegetation, and then it's going to compare that with the map. And so I think we'll have a much better idea of how good our maps are before we start making important decisions with that. So to conclude, I talked about Arbiman Land Mapper, but in a lot of ways, the two projects, the acoustic, the biodiversity monitoring project, and the mapping project have a lot in common. Both of them are using very large data sets. This is something that's becoming more and more common. We're not limited by data in many cases. We're limited by our capacity to turn that data into useful information. In the case of the acoustics, we now have over 1 million 1-minute recordings from many places around the tropics. Obviously, we have many years of satellite information. The trick is to try to produce tools that allow us to extract useful information from that. In both cases, we're using machine learning algorithms to help analyze these data sets. But the thing to me that's most important is that we're developing web applications to make these tools available, not just for us and our research that we're doing, but for the whole community. And the goal is that we have real time, and we've already done this in terms of the acoustic. We have real-time environmental biodiversity monitoring, or at least we're working with the most current data that we can. Okay? So I think I will end with that, and I would appreciate any comments, ideas of how we can, I'm more than happy to talk about the results of land use change in Latin America, but the one thing that I'm hoping to get from you guys is ideas on what you think, how useful this tool could be, how we can get this to more people, and what should be the next step. Thank you.